So in this video we are going to discuss in detail about FCFS, like first come first serve algorithm using C. So initially we are going to declare the header file stdio.io.h for maintaining that input output process. So next is I created a structure named process. So like I created two variables in that. So this we have already done in C++ too. So this is another way of implementation, like we are putting the same code in C. So the process ID and burst is going to get the detail about the process, and then I've created a list of process of which you can say it as 10. Then I created a main function, and the main function should return something. So return 0, 0 means it is a normal termination. So I created two variables, I and n. So I is the purpose, I serves the purpose of usage in the for loops, and n is used to get the number of process that is we need to create this algorithm, how many processes are there in this algorithm, in that way. So initially we have to use Printf and Scanf statement. So Scanf it is used to read the input from the keyboard. So the %d represent that it is of integer type, so we have to use %d. So ampersand n, it is it is going to store the value in the address of n. So next is for loop I is equal to 0, I less than n, which means that suppose I entered n value as 3, so it will take the value from 0 to 1 and 2. So here I am getting the the process ID, and I'm going to get the input of the burst time of the process. So it is initially we are not discussing in detail about the arrival time of the process. We are only considering the process and the burst time. Here we are taking that all the processes are appearing in the coming to the ready queue in the same time. So initially we are categorizing the first input is given as the first process that we need to process, then the second and the third, in that way. Okay. So I got the input. Now I'm going to print the input and see. Again I'm writing one more for loop to print the input. What is that we have got in that way. So %d, the space, we have to leave some space to print the value of process ID and process burst time by including a space in the output. So leaving the space between the %d makes that it will leave the same amount of space in the output. Putting first %d, it is going to be printing the output of process ID, and then it is going to print the output of burst, the second %d. I'm leaving some amount of space here so that the output will be much clear for us to read. /n, so it will make the new line character. It will leave some space. Here also I will include some endl, which is to leave some space. Okay, I'll run and check. Enter the number of processes, so I will say 3. Okay. Something is wrong with it. What is that wrong? Check again. Code is correct, I think, on that. It is wrong. Okay, so I didn't I put %ampersand. I left the ampersand there in that p of I dot burst. That is the reason. So it is not getting the input burst. So that is it is not responding in a proper way. Okay, now it is working fine. So just to check, like the first process and second process and third process, 2, 4, 5 is the burst time of the burst responding process. So it is working fine. Now we can print the process name, labeling things to give a proper output for us. So just above the where I have printed the process name and burst time, just above that I am printing the process name and the burst time, so that like it is a label thing for the process and the burst time. Okay, now I think the output will be much clearer. I have to put an endurance because the output, the formatting of output is not so clear, so I'm just including like the slash in there. So now it is clear. The process 1 is taking the burst time of 2, and that way the output is much clear there. Now to like for each time when I'm getting the input, while giving the input it is not so clear, so I'm putting slash in the printf statements. So it is like whenever the cursor is blinking, it will blink in the next line, it won't blink in the same line. Let's check now. Okay, 3. Now the cursor automatically comes down, so the slash in works fine. Okay, so now the process 1, 2, 3 and burst time 2, 3, 4. Now we can bring the Gantt chart and check. Gantt chart and the slash n, I think slash n we can give here itself. So the next thing will be going down. You know that the first come first serve, like it is an algorithm which is going to print the first coming process. That is, it is going to process the first process, and then again it will go to the second one, and then that in that way it won't take like shortest job or any other concern. So we are going to print the Gantt chart like we need not rearrange any process. We're just going to print the process as the way it is coming. So I'm printing this process ID here. Process ID is alone enough. P of I dot process ID. Semicolon, and I'm going to print a new line like or /t, so that it is going to leave some tab space between the process. So Gantt chart, like it is going to put the process in the middle, and then the left hand side will contain the starting time of that process, and the right hand side it will be containing the ending time of the process, like how much time it is taking. For example, 0 to 5, or what is the burst time, 0 plus the burst time of the process. That way it will be going on. Now we are going to put the burst time, like we already did this in the previous algorithm in C++2. So int temp, I'm just we can name it as any variable. Int temp is equal to 0, and I'm putting for loop, and I'm going to print the temp variable first. So the left hand side initially it will be starting with the starting value of temp. So here the temp value is initially 0 that we have set now. So I'm just printing the temp. So %d I have to put, and then temp %d. So remember this, like in the previous, if you are using oldest compiler of C, you cannot declare the variable wherever you want. The variable declaration should be in the first line in the old C process, old C compilers and all. So this is a new one, so I am declaring the variable like we are doing in any other languages. We can declare the variable at any point. So I am putting /t that to leave the tab space between the temp, like the starting initial state of that process to the burst time. So there is a tab space. So next is like temp plus p of I dot burst, so that the initial starting point of that process is 0, and then I'm adding the burst time of the particular process. So it is carrying on, like temp will be repeated again and again. So I'm leaving one more tab space here. I have printed the temp too, so I think it will be working fine now. So what I'm going to do is, like, I missed, just you can run and check. Oh, there is some error here. I missed that percentage %d here, so I need to put that percentage %d. Now we can run and check. Just you can give random inputs. So the process name is like 1 to 3 and burst times 24, 4 and 2. So Gantt chart doesn't look good, but we got the output as 0 to 24, 24 to 28. The first process is 0 to 24, second process is 24 to 28. The output looks fine, but we need to indent the output. I will need to add some line feed. I can add here. So /n, it will bring the output to the next line. Hope so. We'll run and check. Some random outputs. So you can clearly see here the first process is running between 0 to 24, and the second process is 24 to 29, and the third process is 29 to 31. You can check 24 plus 5 plus 2, 31. It will be coming there correctly, but we can indent the process too. Like the process number is like somewhat little bit too close, so I am putting /t, another /t there. Now we can run and check. Some random inputs. So the indentation should be clear, like it should be really like looking like a Gantt chart. So first process is 0 to 24, it is clear, and the second process is 24 to 28, that is 24 plus 4, which is 28. Then the third process is from 28 to 29, because we have given the burst time as 1. So it is working fine. We have generated the Gantt chart for the FCFS, like the process for the process given. Now we can go for the other thing, like waiting time and the turnaround time one by one. So first we will put an waiting in the structure. We should be clear that the first process won't wait for anything, like it will be starting its process once it is reaching the ready queue. So we can initialize p of 0, whatever the process that is coming, as 0, because it won't wait for anything. So I'm adding it as like 0 for the first process. Waiting time of the first process is 0. And then like here we can initialize the value of other processes to temp, because the temp will hold the value of the process. Here we need to put like if I not equal to 0, because we need not to initialize the first process, like because the first process is initialized already, which is to 0. We need not change the value of that. So I am putting like I not equal to 0, which means that the first process need not be changed. The other process need to change to temp variable. That will be working fine. You can see in the output. So I'm printing the output as of now. So we'll introduce a for loop here, and I'm putting like printf %d, and I'm leaving some space %d. So we need to print the process. Okay, process name and the burst time, process waiting time. The process waiting time, we can print that process waiting time. So it should be clear that the waiting time will be the amount of time that is a process is waiting in the ready queue before execution. That is the time that you have to take. So next is the printf, and we can check the output of that. So for that we are written, we need to check the output. I'll add a println here, like to leave that line spacing here also. So now we have calculated the waiting time of each process. So you can run and check the program. So the same simple outputs, simple inputs you need to check, give, and I can check. So the waiting time for each process is calculated. The first process is waiting the 0 time, I like 0 minutes, so because it will run while the starting itself. The second is taking like 23 timing, let me say it as seconds. So the third one is waiting till 28. So it will be waiting like for the previous process to complete. Next we can calculate that the average waiting time. So that I'm introducing two variables, which is like TW, I mean WT waiting time and average waiting time. Whatever the variable you want, you can declare. I will initialize the WT to 0, so that like it will be clear for you to initialization is important, because it will, or else it will take some catchy value and it will print give some false information to us. So we have to initialize the variable. Now we can put like WT is equal to WT plus P of I dot waiting. So we are going to add the waiting time of all the process in the WT, so that you can calculate the average waiting time. Okay, so average waiting time will be like waiting time divided by n. Now we can print and check the average waiting time. So equal to percentage %d and average waiting time. You need to add that average waiting time as a label there. So variable name is avgw. Now we can check the output and see whether we are getting the average waiting time in the correct way or not. So the average waiting time is 17. You can see that 0 plus 24 plus 27, it will be around let me say 52. So like 52 divided by 3, it will be 17. So it's clear, like I'm printing like integer value, so if there is any decimal point, it will be terminated. Now we can go for turnaround time. So turnaround time means like the amount of time spent by the process in the ready queue, like for the what you can say, like the total amount of time taken by a process to complete its execution, that is called as a turnaround time. So we can calculate the turnaround time. Since we are not calculating any arrival time, it is easy for us to calculate the turnaround time. Simply we have to initialize the turnaround time to that say like P of I dot tan is equal to temp, because like the entire burst time, it will be there in the temp. So I'm just printing the turnaround time here. In the previous scenario, like before incrementing the temp variable, we have taken as a waiting time, because it will be taking the left hand side of the process in the Gantt chart. To take the right hand side of the Gantt chart, you need to assign P of I dot tan is equal to temp, so that we'll get the right hand operand of that in the Gantt chart. So we'll check now. So the first is like waiting time, turnaround time is 24, 29 and 33. It is clear that we have calculated the turnaround time for each process. Now we can take the average of turnaround time. It is same as like what we have done for that waiting time. We have to initialize that EU, that is turnaround time, to 0, and turnaround time is equal to turnaround time plus P of I dot tan. The tan is a variable which is going to hold the turnaround time of each process. Then we can calculate the average. So the turnaround time means like it is going to be the right hand side of the Gantt chart. Like In the Gantt chart, we have predicted, like we are told that there will be a process in the middle. The left hand side there will be a starting time, and the right hand side it will be the end time of the process. We need exactly the end time for the turnaround time. Turnaround time means the amount of time spent by the process in the queue, that is in the ready queue. So that we can obtain as we done in here in the 45th statement, like there is p of I dot tan is equal to temp. Because the 44th statement tells that we are adding the burst time of each process with the temp. So now we have calculated the average, so you can run and see. So we got that turnaround time average is 6. So it is like 2 plus 7 plus 9. It will be coming around 18 divided by 3 6. So 18 times 3 for this thing. 2 plus 7 divided by 3, which is 3 actually. So we have completed this program.